Welcome to Ask and Learn.
We want to produce graphs of f of x is equal to 1 over x to the 8th minus 2 times 10 to the 8th all over x to the 4th that reveal all the important aspects of the curve, and we want to then use f's graph to estimate the intervals where the function increases, decreases, and intervals of concavity. And lastly, we'll use calculus to find these intervals exactly. So I went ahead and just found what I thought was a good viewing window of this graph. And if you just keep on zooming out, it looks like it just goes to negative infinity as x gets closer and closer to 0, because the values just keep getting larger and larger and larger. Okay, so let's just go ahead and find what we get for this. So the function will be increasing when f, so I don't want to talk about the derivative, I just want to talk about increasing. So increasing will be, well, it doesn't look like it's ever increasing because it's getting really close to 0 on the left. And then it just keeps getting smaller and smaller. Or actually, I'm sorry, it is increasing to the right. So it looks like from 0 to infinity, the function will be increasing. And it looks like it'll be decreasing from negative infinity to 0. And then for concavity, well, it looks like it's just concave down on each side. So it just looks like it's going to be concave down, and that just looks like it's going to be from negative infinity to 0, union 0 to infinity. So it doesn't really look like it's going to be concave up anywhere. All right, now let's go ahead and use a little bit of calculus to find what these intervals actually should be. Now, I went ahead and found the derivatives already for both of these functions. So the first and second derivative. And now what we want to do is go ahead and set this function equal to 0. And so doing that, we're going to get that. We really want to solve for when our numerator is equal to 0, or 10 to the 8 times x minus 4 minus 1 is equal to 0. And if we go ahead and solve that, that just gives us x is equal to plus or minus 1 over 100. So what this implies is we possibly have 2 points where it's going to be a maximum or a minimum. And now let's go ahead and solve for where f prime of x is strictly larger than 0. So f prime of x is strictly larger than 0. Well, I went ahead and solved for this beforehand as well, otherwise it was going to make the video way too long. So it's greater than 0 on the interval negative 1 over 100 to 0, union 1 over 100 to infinity. Oh, and so this here is increasing, and it's decreasing when f prime of x is strictly less than 0. And this was just the rest of our interval for our domain. So negative infinity to negative 1 over 100, union 0 to 1 over 100. Now these two intervals are different from what our original graph was. So we obviously didn't have a good enough viewing window, at least for our x values, because it seems for very small values we have things going on. Or I should say numbers with very small absolute value. All right, now we're going to do the same thing over here. We're going to set this function equal to 0. And that's going to say we need to figure out where 10 to the 9th times x to the 4th minus 18 is equal to 0. And solving for that, we would get x is equal to plus or minus the 4th root of 18 over 10 to the 9. And this here is approximately equal to plus or minus 0.011. And now using this, we can go ahead and solve for this inequality of f double prime being strictly larger than 0 or the function being concave up. And I went ahead and did that already, giving us negative fourth root of 18 over 10 to the 9 to 0, unioned with 0 fourth root of 18 over 10 to the 9th. And this function is going to be concave down when f double prime is strictly less than 0 on the rest of our domain's interval. So negative infinity to negative fourth root of 18 over 10 to the 9 union fourth root 18 10 to the 9 to infinity. And so if we were actually to use these critical values of these inflection points, we could actually see that a nice graph of this actually looks like this here. So it wasn't an issue of we didn't go up and down enough. It was an issue of we weren't close enough to the y-axis to actually see everything that was going on. So what this is to say is sometimes these graphs that we originally have, like here, while if you were to just zoom straight out or to just zoom straight in, you would never really see what is going on, because if you just keep on zooming out forever and ever and ever, or at least for a very long time, it just looks like it's going to negative infinity unless you really get far out, and by that time that line will just look like a blimp, so you can't really see that it's going to positive infinity actually. So this here is a nice little graph of it, and the viewing windows we would actually want to use would be between negative 0.05 to 0.05, and for y, negative 10 to the 6th to 10 to the 3rd.